Solve one problem on free torsional vibrations of a geared system considering inertia of gears.
Let us understand some important concepts related to free torsional vibrations of geared system with considering inertia effect of the gears. It is treated as three-rotor system. If we observe the diagram here, this rotor A connected to the pinion and this gears is connected to the rotor C. So in the first part, if we observe, this rotor A is having mass moment of inertia Ia, this pinion P is having mass moment of inertia Ip, and the length of the shaft connected to this having length L1 and diameter D1. Now in the second part, here is the gear with mass moment of inertia Ig, and this is the rotor C with mass moment of inertia Ic. Now for the second part, length of the shaft is L2 and diameter D2. So this is the actual system. Now we have to draw the equivalent system. So because we have to consider the inertia of the gears, we have to introduce new rotor as a P dash with mass moment of inertia I dash B. Now what this I dash B represents? So I dash B represents combined effect of inertia of pinion and gear. So how to find out this I dash B? So I dash B is equal to IP plus Ig divided by Gr square. Now here the third rotor is C dash. So instead of C we have to take here as a C dash. And how to find out this I dash C? So I dash C is equal to Ic divided by Gr square. So Gr is gear ratio. So how to find out this gear ratio? It is the ratio of omega P by omega G. That is the angular velocity of pinion by angular velocity of gear. Now we will draw here the node diagram for this equivalent system. So if we observe, this is the three rotor system and there are two nodes. So node in between A and B dash is N1. So this node point N1 for which the amplitude is 0. Now initially we will consider the amplitude of rotor A is in upward direction. So I will draw here amplitude of A. So we will give here this amplitude as A1. So this amplitude is A1 is in the upward direction. Now we will join this end point and N1 and we will extend this line. So here below this B dash, here is the amplitude of B dash. So if we observe, we have to connect this line with the position of this B dash. So here we will join this. So this is the amplitude of B dash. So amplitude of B dash we will take here as A2. So I will show here. So here is amplitude A2. Now here is the next, that is the second amplitude N2 in between B dash and C dash. So again this end point of A2 we have to join with N2 and we have to extend this. So if we observe again at this position, here is the amplitude of C dash. So we have to connect this line with this point. So here is the amplitude A3. So again we have to show this. Here is the amplitude A3. So here is A, here is rotor B dash and here is rotor C dash. So this node diagram is completed. So if we observe, this rotor A and C dash rotate in same direction while B dash rotate in opposite direction. Now how to show the length of this node point from rotor A and rotor C dash as well as from rotor B dash. So we know that this is the equivalent length, that is equivalent length of the system is L1 plus L3. So what is the distance of this N1 from this rotor A? That is known as LA. That is the distance of node point from rotor A. That is node L to the base A. In the same way, distance of node point N2 from C dash. So here we will show. So this is known as LC. And now if we observe distance between A and B dash is equal to L1. So how to calculate this remaining distance, that is L1 minus LA. That is, this L1 minus LA is the distance of node point N1 from B dash. Now how to calculate the distance of node point N2 from B dash. So this B dash and C dash total distance is L3. So we have to calculate remaining distance L3 minus LC. So that is the distance of this node point N2 from B dash.
Given question, an electric motor rotating at 1440 rpm drives a pump at 500 rpm through a pinion gear arrangement. The motor armature has a moment of inertia 400 kg/m² and the pump impeller has an inertia 1400 kg/m². The pump shaft is 450 mm long and has a diameter of 90 mm, whereas motor shaft is 180 mm long and has a diameter of 45 mm. Find the natural frequency of the system. If mass moment of inertia of the pinion is 8 kg/m² and that of gear is 24 kg/m², assume modulus of rigidity to be 80 × 10⁹ Newton/m².
Let us understand given data with the help of diagram. In question, motor pump system is given. As the motion is transmitted from motor to the pump through a pinion gear system, we will consider rotor A as a motor, rotor C as a pump. Mass moment of inertia for motor Ia 400 kg/m², for pinion 8 kg/m², for gear 24 kg/m², and for the pump, that is IC, 1440 kg/m² is mentioned in the question. The length of the shaft connected to the motor and pinion is 0.18 meter and diameter 0.045 meter. The length of the shaft connected to gear and pump L2 0.45 meter and D2 0.09 meter is also mentioned in the question. Now the motor runs at, that is NA, 1440 rpm and the pump runs at, that is NC, 500 rpm. Now from this given data we can calculate the gear ratio. So gear ratio is NA by NC, that is equal to 2.88. Now we will first calculate the equivalent length to draw the equivalent diagram. So this is the actual diagram, and when we draw the equivalent diagram, in this question we have to consider the inertia of gears. So we have to introduce here the new rotor, that is for the combined effect of the pinion and gear, that is B dash. And the mass moment of inertia is I dash B. And instead of rotor C, we have to introduce here the I dash C. So we will first calculate equivalent length. So this equivalent length is equal to L1 plus L3. So how to calculate this L1? So we have to take the reference for this actual diagram. Now for the equivalent system we have to consider the uniform diameter of this shaft. So we will take here the D equivalent is equal to D1. So for the first length, that is the length of shaft in between A and B dash, we will calculate as, that is LQ1 is equal to this L1 multiplied by D equivalent by D1 raised to 4. But D equivalent is equal to D1. So D1 by D1 raised to 4, that is 1 raised to 4. So how we can write here, that's L. So if I write L1 into D1 by D1 raised to 4, which is equal to L1. So for this first part, what is the equivalent length? That is 0.18 meter. Now we will move to the second part, that is we have to calculate LQ2, that is the equivalent length in between B dash and C dash. So again we will refer here the actual diagram. So here we will take LQ2. So because this is the gear and pinion system, we have to also take the reference for this gear ratio. So here we have formula to calculate LQ2 is equal to L2 into D equivalent by D2 raised to 4 multiplied by gear ratio square. So D equivalent is nothing but D1. So how we can write here? L2 into D1 by D2 raised to 4 into GR square, that is gear ratio square. So here the second equivalent length we have shown with L3. So we will write L3 is equal to 0.45 into 0.045 by 0.09 raised to 4 into GR, that is 2.88 square. So when we solve this, we will get 0.2331. So how to calculate total equivalent length? That is LQ1, that is 0. Here L1 is 0.18. So 0.18 plus 0.2331, that is 0.4131 meter. Now we will calculate the mass moment of inertia of the rotor B dash and C dash in equivalent system. So I dash B is equal to IP plus IG divided by gear ratio square. So when we put value 8 plus 24 by 2.88 square, which is equal to 10.89 kilogram meter square. Now we will calculate I dash C. So I dash C is equal to IC divided by GR square, that is 1400 divided by 2.88 square, which is equal to 168.78 kilogram meter square. Now we will find out the distance of the node points N1 and N2 from the rotor A and C dash in the equivalent diagram. So we know that the distance of N1 from rotor A is known as LA. So we will show here. And the distance of node N2 from C dash is known as LC. Now how to find out the distance of these nodes from B dash? So this total distance between A and B dash is L1. So L1 minus LA is the distance between N1 and B dash. And the distance between B dash and N2 is L3 minus LC. Now we have to find out the value of LA as well as LC. So we have first condition, that is for these rotors A and C dash, IALA is equal to I dash C LC. So this is the node points from the equivalent diagram. So we have to take I dash C. So if we put the value, then we will get the relation in between LA and LC. So LA is equal to 0.42 LC, and this is the equation number 1. Now we will take the relation in between the rotor A and this rotor B dash. So how to find out this? So we have one condition, 1 divided by IALA is equal to 1 divided by I dash B in the bracket 1 divided by L1 minus LA plus 1 divided by L3 minus LC. So from the diagram we can take this value L1 minus LA and L3 minus LC. Now we will put the value. Now if we observe, we have relation in between LA and LC. So we have to replace this LA. And we will take the whole equation in terms of LC. So instead of LA, we will write 0.42 LC. So 1 divided by 400 into 0.42 LC is equal to 1 divided by 10.89 in the bracket 1 divided by L1. So L1 value is known. 0.18 minus, instead of LA, 0.42 LC plus 1 divided by L3. So L3 is also calculated 0.23 minus LC. Now we will simplify this. We will take this term to the right hand side and it will become 0.0645 by LC, which is equal to. Now on the right hand side we have to solve this bracket only. So we will take this denominator term to the numerator and this denominator term to the numerator of this second form. So here, and for the denominator we have to multiply with these two terms. So when we take this, then 0.23 minus LC plus 0.18 minus 0.42 LC. So here is the plus sign. So if we take the bracket or remove the bracket, the sign will remain same. And in denominator we will take the multiplication 0.18 minus 0.42 LC multiplied by second bracket 0.23 minus LC. So we have to multiply these denominator terms to each other and we have to simplify this numerator. So when we simplify this numerator, then 0.41 minus 1.42 LC, and when we simplify this denominator, then 0.42 LC square minus 0.27 LC plus 0.0419. Now we have to take the cross multiplication. So when we take the cross multiplication and we will simplify this, we will get the term 1.44 LC square minus 0.43 LC plus 2.7 into 10 raised to minus 3 is equal to 0. So this is the second order equation. So for the second order equation, how to find out the value? So we have one formula and we will find out the values for the LC. We will give the notations. Coefficient of LC square we will consider as a coefficient of LC B, that is B is equal to minus 0.43 and this constant value as a C. So how to find out the solution? So we have formula minus B plus minus under root of B square minus 4AC divided by 2A. So we will put the value. So minus into minus 0.43 plus minus square root of B square, that is minus 0.43 square minus 4AC, 4 into 1.44 into 2.7 into 10 raised to minus 3 divided by 2 into A, that is 1.44. So when we take this plus sign, we will get one answer, and when we take this minus sign, we will get the second answer. From the value of LC1, we will calculate the value of LA1 because we have relation in between LA and LC from equation number 1. So value of LA1 0.1228 and from the value of LC2, value of LA2 2.7 into 10 raised to minus 3. Now we will plot the node position diagram for the equivalent system. So we will take the first set, that is LA1 and LC1. So if we observe LA1 is 0.1228 and LC1 0.2911. So if we observe the distance of node position from the rotor C is 0.2911 but the L3 is 0.23. So we will first take this point, that is the node position from the rotor C dash. So we will draw here one horizontal line for the rotor C dash. We will take here C dash, here is B dash and here is rotor A. Now we have to compare the values because here LC1 is greater than L3. Now we will take this LA1. So where is the node position from the rotor A? So if we take the difference, that is this total equivalent length 0.18 plus 0.23, that is 0.42. This total equivalent length is 0.42. So this 0.42 minus 0.2911 is 0.1289. So the remaining distance is from the rotor A is 0.1289 and the node position from the rotor A is 0.1228. That is, this is smaller distance. So for LA1 the node position is here, that is point N1, and from LC1, that is from C dash, node position is here, that is N2. So we have to show this node position. So we will compare this by calculating this because the total distance 0.42. So when we plot this node point N2 from C dash, that is 0.2911, then the remaining distance is 0.1289. So this remaining distance is 0.1289 and here the node position from the rotor A is 0.1228, that is smaller distance. So here is the node N1. Now we will consider the amplitude of C dash is in the upward direction. So this is our consideration. Now this is the end point of amplitude and we will join the N2 and this end point because N2 is the node from this rotor C dash. So here this distance is from C dash to N2 is LC1 0.2911. Now here is the B dash. So here amplitude also in the same direction because we have to join this line. So this is the end point of the amplitude B dash. Now again we will plot the LA1, that is the node point N1 from the rotor A. So this distance is 0.1228. So this is the node N1. Now here is the end point of B dash. So we have to join this end point of B dash and N1. So we will join this. So when we join this, again from this rotor A we will join this inclined line. So here this is the line below this horizontal line. So from this diagram we come to know that this rotor B dash and C dash rotate in the same direction because amplitude are in the upward direction, and this rotor A rotate in opposite direction. And this is the one node arrangement diagram. Now we will move next set, that is LC2 and LA2. Now LC2 is 0.0064. So here is the rotor C dash. Now this distance is so much small as compared to L3. So here we will take this first node, that is N1, and LA2 is 0.0027. So again this is the very small distance as compared to this distance, total distance L1, that is in between the rotors L1. So here we will take the next N2. So we will plot here A. This is the position for B dash and this is for C dash. So again we will take the amplitude of C dash in the upward direction. So first, for the first rotor we have to assume any direction of the amplitude. So we have assumed here this C dash is in the upward direction. Now we have to join this N1, this point N1, and we have to join the end point of this amplitude. Now we have to extend this. So again we have to join the vertical line from the rotor B dash to this line. So this is the amplitude of B dash. So this is the end point of amplitude B dash. Again we will join this end point and the node point N2. And again we have to join the line from the rotor A. So here is the amplitude in the upward direction. So if we observe, amplitude of A and C dash are in same direction. So direction of rotation is same. But B dash is in the opposite direction. So direction of rotation is in the opposite direction. Now we have to show the distance. That is, this distance is LA2. So we will show here LA2. And here this distance between C dash and N1 is known as LC2. And this is the two node arrangement diagram. Now we will calculate the natural frequency for the one node arrangement. So formula is Fn1 is equal to 1 by 2 pi under root of G J equivalent divided by IALA1. Or we can also write the formula 1 by 2 pi under root of G J equivalent divided by I dash C LC1. Now here G is the modulus of rigidity which is mentioned in the question. J equivalent is the polar moment of inertia for the shaft, and it is calculated by using formula pi by 32 D equivalent raised to 4, that is equal to pi by 32 into 0.045 raised to 4. Now here for the one node arrangement we have to take the distance of the node point from the rotor A. So we can use any one formula. So we will take the first formula. So LA1 is equal to, we have to take 0.1228, and then IA, that is the mass moment of inertia for the rotor A. Now when we take the second formula, that is 1 by 2 pi under root of G J equivalent by I dash C LC1, then we have to take the distance of the node point from the rotor C dash, that is 0.2911, and we have to take the mass moment of inertia for the rotor C dash, that is I dash C. So answer is 4.07 Hz. Now we will move to the two node arrangement diagram. Here we have to use suffix 2, that is Fn2 is equal to 1 by 2 pi under root of J equivalent IALA2, or we can use the second formula 1 by 2 pi under root of J equivalent divided by I dash C LC2. So here LA2, that is the distance 0.0027 we have to use, and Ia, that is the mass moment of inertia for the rotor A. Now if we take the second formula, then LC2 we have to take 0.0064 and I dash C, that is the mass moment of inertia for the rotor C dash, that we have to take. So Fn2 is equal to 27.46 Hz.